Hello, and welcome to this video about cloud computing. This photo shows our recently completed prototypical cloud computer box in a workbench environment. This box has been several months in development. However, now we can put new boxes in place either for ourselves or for our clients at their locations using our current capabilities at the rate of about one new box per week as needed. The cover of the prototypical cloud computer box has been removed so that you can see inside. It measures about 17 inches by 8 inches by 30 inches and is now installed in a Dallas, Texas data center connected to the internet. Our cloud computer functions as part of what I call a cloud computing community. Here is how a cloud computing community is put together. The client's computer can be located almost anywhere, represented by blob 1. Client computers can connect to our cloud computer with Mikogo for online collaborative sessions, item 2. Clients can move data into and out of the cloud via FTP, which is also known as File Transfer Protocol, and is represented here as item number 3. There are 3 graphics workstations, items 4 through 6. A 4th workstation is for FTP service, and that is item 7. We have 4 slots reserved for future expansion, which is shown here as item number 8. Using a remote desktop connection or Mikogo, which is items number 9 through 11, or FTP, which is item number 12, the cloud can service 3 users, which is represented here by items number 13 through 15. This can be increased to 7 or 8 users depending on whether we continue to dedicate 1 workstation per admin and FTP service. Also, 8 users are assumed to be the practical limit for work sharing in a single project Revit file. Our cloud computer uses FTP remote desktop connection and Mikogo for data management and telecommunications. Let's take a brief look at each process. We'll start with FTP. Here is a hard drive folder tree on my local personal computer in Jupiter, Florida. Here is a hard drive folder tree for the FTP server in our cloud in Dallas, Texas. We use FTP to move, copy, and delete folders and files like this. You can see now that the file I selected on the cloud has been copied to my personal computer here in Florida. This is the remote desktop connection dialog box for my local computer, which we use to connect to our cloud. And this is the desktop in the cloud. This is a Revit architecture file in the cloud, and we use the cloud to run applications remotely. Here is how Mikogo works. My local computer is logged onto the cloud and illustrated in the window on the left. Inside that window and inside the cloud, I have started an online session in Mikogo where the cloud computer is functioning as host. I will call the online computer the facilitator. The window on the right is my computer here in Jupiter, Florida, pretending to be another remote computer logged onto the cloud via the Mikogo session. I will call that right-hand screen the other guy. We could have a lot of other guys in addition in this session if we wanted. The facilitator is sharing his desktop and is in control of the cursor, but in actuality, I am controlling the facilitator from my personal computer via remote desktop connection. I'm actually, virtually speaking, the facilitator, but I speak of the facilitator as a separate person. At any time the facilitator chooses, he can pass cursor control to the other guy and then take it back. He could also take desktop control and give it to the other guy, but unlike ordinary Mikogo sessions, and because this is a virtual session, the facilitator would not be able to get desk control back, so the facilitator never shares desktop control. We use Mikogo sessions for clients to access the cloud to preserve time for production users who are doing actual production work on the cloud using more efficient and faster remote desktop connection. The facilitator has just pulled up a Revit architecture file on the host computer on the left-hand window, and of course it also comes up on the right-hand window. I'm going to have him do some pans and zooms. The facilitator's pans and zooms are almost instantaneous to my mouse movements, which I am controlling on my local computer. However, there is a noticeable lag time between the movements on the left-hand window and the right-hand window. That is the result of latency, and I will now explain latency in more detail because latency is very important in determining the best geographical locations for users. Geographical proximity between a cloud computer server and its respective remote users is a key factor in determining cloud computing speed. Cloud computing speed decreases as distance increases. Speed is measured by recording the length of time required for a signal from a remote user to travel to the cloud server and back. This measurement is expressed in milliseconds. It is customary to reference this measurement as latency. I want to demonstrate for you the impact which distance has on cloud computing. I made a collection of screenshots of the website www.speedtest.net. This is a website where we can measure latency. We can test locations throughout the world. Since our cloud, where we were logged on, is in Dallas, Texas, all of our measurements for this testing were to and from Dallas. The first test was between our Dallas cloud computer and a Dallas-based data processing center. The time in milliseconds for the Dallas to Dallas test was 5 milliseconds. That's less than 1/100th of a second. Just in case you might be interested, this site also tests the downstream and upstream bandwidth, which in this case was 3.65 megabits per second and 8.82 megabits per second. Now let's do a test between Dallas and Miami. That turned out to be 35 milliseconds. That's slower, but still respectfully fast time, less than 1/10th of a second. Finally, let's do a test between Dallas and Changchun, China. That turned out to be 920 milliseconds, which is quite slow, almost a full second. Anything less than 100 milliseconds is okay as far as I can tell. When you get up to the kind of time we measured between Dallas and places like Changchun, China, the long-term results will be operator fatigue and loss of productivity. Generally speaking, latency will fall within acceptable limits for a cloud computer server located in places such as Dallas, Texas, and any remote user in North or Central America or the northern portions of South America. Connections between Dallas and locations farther away are not recommended. This concludes the video on BIM-CAD cloud computing. I'd like to keep you updated about our cloud. If you linked to this video from an email from me, then you really don't have to do anything. I'll send you emails about once per month. You can unsubscribe at any time you choose. If you linked to this video via our company website or YouTube, and I don't have your email address and you'd like to keep updated about our cloud, then email me at archline@archline.com and I'll put you on our mailing list. If you need help, give me a call. Tell me what you need. One business day later, I will email or fax a no-obligation proposal written especially for you. All of us with archline.com are looking forward to working with you.